Uh, uh, Hello everyone. So today I am starting the next part of the frequency divider circuit. Okay, so in this part here I will discuss the frequency divider circuit divided by the even integer firstly f by 2, f by 4, f by 6, f by 10 like that. Okay, and one thing you should remember like that by default we'll use the up counter. Up counter means it will start 0. Yeah, it will start 0, 1, 2, and 3 and 4, 5 like that if we go in the decimal. So by default we'll use the up counter. Okay, it will start from the 0. Okay, this is the thing. So the first example is design the f by 2 circuit. This is the motive. Okay, so how we will design this circuit? So I already discussed in the previous part about the mode value. Okay, so f by 2 means the mode value of is the 2. Okay, so here I will use the mode 2 counter. Okay, mode 2 counter. I am not going the designing of the mode 2 counter. You can design. So using the flip flop. This is the basic thing. I will discuss in the later video. Okay, here I am concentrate. I am concentrate the only to design the frequency divider circuit of the f by 2 circuit. Okay, so this is the thing. So here the mode value is 2. Okay, so mode value 2 means the mode value 2 means it will count only the two state means that is the 0. I have told the up counter it will count only two state, 0 and then 1. Okay, so how we will design? So this is the clock pulse is there, one clock pulse. So that is the input frequency we have already there. Okay, so we have already there, that is the input frequency. So this is the input frequency and clock signal we already given. Okay, now so in the first clock the value is 0. So in the first clock, so that is the first clock. Okay, because it is the time period, no? That is the input time period, that is the tune. So in the first clock the value is 0, and in the second clock it will be 1. So in the second clock it will be 1, then it will be 0, and then it will be 1 like that. Okay, so this is the thing. So what are the time period of that? So this is the time period. That is the T ought is equal to 1 teen and 2 teen. 1 plus 1, that is the 2 teen. So this is the T ought. T ought is equal to teen. If the time period is twice, then the frequency F ought is equal to F in by 2. So this is the designing. So this is the thing. This is the F by 2 circuit. Okay. And one thing also, the how will calculate the duty cycle? So here I designed the up by 2 circuit with 50% duty cycle, means the see here. So in the so this is the total duration of the T out. T out is equal to 2 T. So so in the one half it will be 0, and in the second half it will be 1. So T out is equal to, so T out is equal to, so that is the T in plus T in, that is the T in. So means that is the, so for one T in, for one, so this is the on, so this is the on time, this is the on time, and this is the off time. So off time here or the off time and on time is same. Because of that, so see, so this is the logic 0. So this is the complete teen, and this is the logic 1. This is the complete teen. So T on and T off is equal to T on and T off are both are same. So this is the so T in divided by 2 T in. So T in cancel. That is the 1 by 2. 1 by 2 means 1 by 2 multiplied by 100. That is the 50% duty cycle. So here I designed the F by 2 circuit with 50% duty cycle. The circuit is, that is the mode 2 counter. Okay, so this is the mode 2 counter. This is the input frequency, and this is the effort. You should make, you should make like that circuit. Effort is equal to F and T, and with 50% duty cycle. Yes, of course we can change the duty cycle by the help of the gate. Okay, so no problem. So here I make the F by 2 circuit with 50% duty cycle. Okay, again, I am discussing one more question. So that design the F by 4 circuit with 50% duty cycle. Okay, this is the constant. So you should follow like that. So you need to design F by 4 circuit with 50% duty cycle. So what are the mode value? That is the 4. So here I use the mode 4 counter, and the total 4 state is there. Okay. So I am naming Q1 and Q0 for MSC bit. That is the MSC bit is there. So this thing is the MSC bit, and this is the LSA bit. Okay. And this is the up, by default I will use the up counter. So this is the 00, 01, 01, 2, and this is the 3. Okay. So for first two clock it will be 0, and for next two clock it will be 1. Okay. So just I'm making the one clock cycle, that is for better understanding, to understand like that how I am telling this is the F by 4 circuit. So this is the thing. Okay, this is the one clock pulse I design. So this is the input clock frequency. Okay. Okay. Now, so according to that, so for first two clock it will be, so for first two clock it will be 0. So so that is the clock, so this is the clock 1. So this is the clock 1. Okay. And this is the clock, and this is the clock 2. So for clock 2, so for first two clock it will be uh, 0. Okay. And next two clock it will be 1. So this is the first clock. Okay. And this is the next two clock, it will be 1. After that it will repeat. That is the 0, 0, that is the 1, and that is the 1 again, it will repeat. So this is the time period of 1 clock. So T out here, the T out is equal to, that is the T in, that is the T in plus T in plus T in plus T in, that is the 14. So T out is equal to 14. Okay. If the time period is 4 times, then the frequency f out is equal to f in by 4. Okay. So this is the f by 4 circuit. So this is the f by 4 circuit. Okay. So this is the f by 4 circuit. So and oh yeah, so you can also calculate the percentage duty cycle. So so this is the very easy thing. Now you have a better idea about that, the percentage duty cycle. So here you can see the T on and T off in also same. So this is called the T off, and this is called the T on. If you tell that is the 2 T in, uh, divided by 2 T in plus 2 T in, 2 T in plus 2 T in. Okay. So 2 T in, that is the 14, 2 T in, T T in cancel, 2 by 4, that is the 1 by 2 into 100%. So this is the 50% duty cycle. Okay, no issue. So f by 4 with 50% duty cycle I make. So here I will use the mode 4 counter. Don't worry about the mode 4 counter. I am using here directly. This is the very easy thing, and I assume that you have, how can make this thing mode 4 counter, you know about already. If you don't know, so in the upcoming video I will take one session, and I will explain everything. Okay. So this is the effort by sorry, that is the effort is equal to, so this is the thing, all the thing related to the, sorry, so this is the so this I make, तो यहाँ पे मैं f by 4 सर्किट बना चुका हूँ. That is the effort is equal to f in by 4. Okay. तो so in the interview only you need to design that thing, that is the mode 4 counter, f effort is equal to f n by 4, and that thing, this is the clock diagram. How will, so how I am telling, this is the f by um, the 4 circuit. So easily you can design, no problem, with 50% duty cycle you design. Okay. This is so so this is the very so this is the very easy thing. If anyone tell like that, design the f by 6 circuit, f by 6 circuit you can make, the f by 8 circuit you can make, f by 10 circuit you can make. Okay. So this is the easy thing. Okay. So here in this part I cover the f by 2 circuit and f by 4 circuit. okay, with 50% duty cycle. Yeah, of course, duty cycle we can also change by the help of the external gate. Suppose, yes, suppose here I'm taking again the f by 2 circuit. Okay, f by 2 circuit, and but in this case, the design the f by 2 circuit with the 25% या 75% duty. Suppose in this case you need to design the 25% duty cycle f by 2 with 25% duty cycle. So f by 2 circuit with 25% duty cycle मैं यहाँ पे भी बना सकता हूँ आराम से. बस मेरे को क्या करना है कि एक्सटर्नल गेट यूज करके ना उसके ड्यूटी साइकिल को चेंज करना है. बस ये चीज में हम लोग को सीखना है. बस दैट थिंग यू नीड टू लर्न. सो हाउ वी कैन चेंज द ड्यूटी साइकिल. External gate, sometimes anything we can connect at the output and we can change their the duty cycle, no problem. So f by 2 circuit means it will count the two state only, that is the 0 1. So for the first clock it will be 0, and for next clock it will be 1, then 0, and then 1. Okay, but here the our purpose is to design the f by 2 circuit with 25% duty cycle. But in this section, if I see, this is the f by 2 circuit with the 50% duty cycle I already designed. Okay, but how will convert the 25% duty cycle? So just think. So just think. I mean 25% duty cycle means the waveform it should be look like that. It will be on only in one half. One half means one fourth. So one fourth part. See, if I connected the end gate, if I connected, suppose here I am telling this is the F out, and this is the F in. Okay, this is the F in and this is the F out. If I connected the AND gate with F out and Fn, in this case, so this is the logic 1 and this is the logic 0. So overall it will be 0. Okay, okay. Then again this is the 0 and this is the 0. So this will be 0. But in this case this is the 1 and this is the 1. So in this case only it will be logic 1. After that it will be 0, like that. So this is the one time period. After that the same thing will be happen. That is the 0, and that is the only 1 and and this is the 0 again. Okay, so here we can understand like that. So this is the 0, this is the t by 2, this is the t for input. But here, so this is the 0 part. So this part is the complete time period, that is the 2t. So if I divide if I divide into fourth part, it will be logic 1 in only one fourth. So here the duty cycle is the percentage duty cycle is, so the total fourth part is there. Yeah, I mean fourth part I am making, this is the one, so this is the two part, and this is the three, and this is the four. So only one part it will be one, and the remaining for third part, for remaining part it will be zero. So for 1 by 4 into 100%. Okay, so this is the 25% duty cycle. Okay, so if I connected f in and f on, f in and f on, f in and f out with OR gate. If I connected OR gate, then it will give the 75% duty cycle. Okay, so we can make the different circuit with the different the duty cycle. Okay, so here I design the f by 2 circuit with the 25% duty cycle. Okay, so how I'll make the circuit? आई थिंक आपको कोई इसमें मतलब डाउट नहीं है. मेरे को लगता है कि मतलब सिंपली मेरे को क्या करना, मैं एंड गेट कनेक्ट कर दिया एक इनपुट और एफआउट में. तो ओनली वन पार्ट है ये जो एक पार्ट है इतने में ही मतलब लॉजिक 1 होगा, एंड द रिमेनिंग पार्ट इट विल बी 0. वी मल्टीप्लाई 1 0, दैट इज द 0, दिस इज द 0, ओनली दिस पार्ट विल बी 1, एंड दिस इज द, या टोटल इज द फोर्थ पार्ट इज देयर, 1 2 3 एंड फोर्थ. तो चारों पार्ट में सिर्फ एक बार ही ऑन है, और रिमेनिंग तीन पार्ट में वैल्यू इसकी 0 है. तो 1 डिवाइडेड बाय टोटल 4 पार्ट इंटू 100%. that is the 25% the duty cycle is there. Okay, so here this is the mode 2 counter. Okay, and this is the input frequency, that is the input frequency of in, and this is the effort I designed the f in by 2 circuit. Okay, and again I connected the end gate. Okay, if I connected, that is the end gate. So this is the, okay, this is the f by 2 circuit, f in by 2, but with 25%, 25% it is the our. So the main motive of this example is how we can change the duty cycle. Okay, so boss, just by adding an extra gate sometimes, that is the end gate or gate, like that we can change the duty cycle. Okay, so in this video I discuss the mode 2 counter with sorry, okay, f by 2 circuit with 50% duty cycle, and f by 2 circuit with the 25% the duty cycle. Okay, if anyone asks like to design the f by 6 circuit, so there is the sixth state. So sixth state, so you should count 0 to 5, and for taking MSA bit you can design the f by 6 circuit, no problem. Okay, so thank you. So this is our first part.